Okay, now first time I'll give you what is hybridization. It is the process of intermixing of pure atomic orbital to give some hybrid orbitals. It is a process of intermixing of pure atomic orbitals to give some hybrid orbitals. I mean, mixing of some orbitals takes place, atomic orbital, and after mixing they will produce some new orbital which are called hybrid orbitals. The number of hybrid orbitals produced depends on the number of orbitals involved in mixing. माने हाइब्रिड ऑर्बिटल कितना फॉर्म होगा ये डिपेंड करेगा, मतलब कितना ऑर्बिटल मिक्सिंग में पार्टिसिपेट किया. आई मीन हाउ मेनी हाइब्रिड ऑर्बिटल you will get, it mainly depends on the number of orbitals involved in mixing. If 4 orbitals involved in mixing, you will get 4 hybrid orbital. If 3 orbitals involved in mixing, you will get 3 hybrid orbitals like this. Now, carbon, mainly in class 11 only carbon compounds are required. That's why we'll do carbon compounds mainly. Carbon in its compounds can show 3 types of hybridization. Carbon in its compounds can show 3 types of hybridization. What are these? Number 1 is called Sp3 hybridization. Number 2 is called Sp2 hybridization. And number 3 is called Sp hybridization. तो कार्बन का जितना सारा कंपाउंड्स है आपको ये 3 ही हाइब्रिडेशन मिलेगा. In some compounds you will get sp3 hybridization, in some carbon compounds you will get sp2 hybridization, and in some compounds carbon undergo sp hybridization. I mean, by doing hybridization they will form the hybrid orbitals. After production of hybrid orbital, it will overlap with the orbitals of surrounding atoms and they will produce the bonds. Now, why the names are sp3, sp2, sp? What is the meaning of it? When one s orbital, I mean एक s orbital, combine with 3 p orbitals. One s orbital mixed with 3 p orbitals. Total how many orbitals? 4 na? And that hybridization is said to be sp3 hybridization. I mean one s orbital mixed with 3 p orbitals. When one s orbital mixed with 2 p orbitals, then it is said to be sp2 hybridization. You know, there are 3 p orbitals. One is called px, one is called py, one is called pz. When the s orbital mixed with px and py only, not with pz, I mean when s orbital mixed with 2 p orbitals, then it is said to be sp2 hybridization. Similarly, when one s orbital mixed with only 1 p orbital, then it is said to be sp hybridization. So depending on the type of the compound, carbon can show 3 types of hybridization. You will get later in which compound carbon will show sp3, in which compound carbon undergo sp2, in which compound carbon undergo sp. You will get later. So first time we will do about sp3 hybridization. So what is sp3 hybridization? In this hybridization, it mixed up of one s orbital. See, don't write like this, one s orbital. It will represent the first cell s orbital. So you have to write 1. In word you have to write. I mean 1s orbital. It may be 1s, it may be 2s, it may be 3s, it may be 4s. So 1s orbital and 3. Don't write like this, 3 p orbitals. 3 p orbitals to give 1s 3p, total 4 na, to give 4 hybrid orbitals. To give 4 hybrid orbitals. These 4 Sp3 hybrid orbitals are tetrahedrali arranged with an angle 109.5 degree. I'll explain what is tetrahedral structure, which angle is said to be 109.5 degree. I will tell you later. So how it undergo sp3? See, in case of carbon, if you want to write the electronic configuration according and to energy, 1s have lowest energy, that's why I have written below. 1s2, 2s2 and 2p2, 2px1, 2py1, 2pz vacant. This is called carbon in ground state, as already I have shown you. After that it undergo excitation. After excitation, one electron will jump from 2s to 2pz. 1s will remain same. 2s now contain 1 electron and 2p now 3 electrons, 2px1, 2py1, 2pz1. This is 2px, 2py, 2pz. This is called carbon in excited state. So this is the electronic configuration of carbon in ground state, and this is the electronic configuration of carbon in excited state. After that, the mixing will take place, and the mixing will take place between this s orbital and this 3p orbital like this. This is called intermixing of orbital, and this mixing of orbital is called hybridization. So here one s orbital mixed with 3p orbitals, that's why the hybridization is called sp3. And after mixing, 1s will remain same, 2 electron, and they will form 4 hybrid orbitals of equal energy like this. These are called sp3 hybrid orbitals. Since it mixed 4 orbitals, that's why you will get 4 hybrid orbital, and everyone contain 1 electron. Because in the mixing 1, 2, 3, 4 electrons present, and that 4 electrons you have to distribute like this way. See, 2s have lower energy, 2p have higher energy, but after mixing, when they mixed up, then their energy become same, and that is why all the hybrid orbital will have similar energy, and these are called sp3 hybrid orbitals. And this sp3 hybrid orbitals, their hybrid orbital shape already I have told you, it's like this. Due to mixing of s, one lobe will be larger, one lobe will be smaller. So carbon produce 4 sp3, one sp3 will be present like this, another sp3 will be present like this, another sp3 will be present like this, another sp3 below the plane, it will be present like this. And these are the sp3 hybrid orbitals, which is called the tetrahedral structure, and every one contain 1 electron, and the bond angle between them, all the orbital bond angle is 109.5 degree. And this structure is called tetrahedral structure. Tetrahedrali, the sp3 hybrid orbitals are arranged. This is above the plane, this is below the plane, and these two are in the plane. That's why I have drawn like this way. So in next class I will show you the model, what type of tetrahedral structure means, what type of structure, how this is above the plane, how this is below the plane, and how these two are in plane. So I will show you the structure by taking some model, then you can understand. So when carbon undergo sp3 hybridization, the 4 sp3 hybrid orbitals, they are tetrahedrali arranged like this way with bond angle 109. Similarly, these two orbital also they have the angle 109.5 degree. These two also have the angle 109.5 degree. Every angle will be same, and their angles are 109.5 degree, and everyone contain 1 electron like this. So now this hybrid orbital will overlap with the 1s orbital of hydrogen, and like this way they produce the bond with hydrogen. And since the overlap now same, sp3 1s, sp3 1s, sp3 1s, sp3 1s, since all the overlaps are same, that is why in methane all the bonds are equivalent. I mean their energies are same, their lengths are also same. Thank you for today.